Are you ready for a challenge? If you said yes, then you're in the right place. So if we're solving this system of equations, the only way to do it really is analytically. We notice that we have variables in the denominator. So that's something that's a big deal. Now, normally, when we've solved the equations in the past, what's happened is we've always said, let's get rid of the fractions by multiplying through by the LCD. But through experience, when I've tried to do that with these types of equations, I end up getting in more of a mess than just dealing with the fractions in the first place. So I'd like to save you some time, and I'd like to kind of encourage you. It's a lot better if you want to work with the fractions and just consider them as whole terms themselves. So if you could kind of deal with the 3 over a, 1 over a, 5 over a, that's kind of like your first terms of each of the equations. 5 over b, 2 over b, 4 over b as your second term in the equation. And 2 over c, 1 over c, and 1 over c as your third term in the equation. You can approach this in the same sort of manner we were dealing with the other examples. So the first thing that we're going to notice is that there are no variables missing in any of the three equations. They all have a, b, and c. Just for purposes of labeling and kind of referencing back, I'll do the whole 1, 2, 3 again. And then now it's kind of your choice. You know, you can kind of play around with who would I like to eliminate, or which fraction would I like to eliminate. So as I'm going through these, I kind of notice, you know, I can eliminate fractions as long as their numerators are opposites. So you can choose any of the variables, but what's kind of yelling at me at the moment is equation 2 and 3. Reason being is that they both have a 1 over c. So it might be a little easier to work with. So I will do that. And just be patient with these. Take your time to write them out. So 2 is 1 over a plus 2 over b plus 1 over c equals 1. And 3 is 5 over a plus 4 over b plus 1 over c equals -1. Now, instead of me just eliminating a particular variable, I'm going to consider eliminating the actual term. So when I'm thinking to myself, saying self, I'm going to eliminate 1 over c. So not just the c, but the 1 over c. And how I can do that as far as my goals would be, I would need a 1 over c and a -1 over c for these to neutralize out. So if you could kind of look at what we're dealing with, we already kind of have that case in equation number 2 or 3. We already have a 1 over c. So if we want to, I'll just rewrite this over again. I have 1 over a plus 2 over b plus 1 over c equals 1. My goal would be to multiply equation 3 by -1 on both sides. Now, if I do that, the fractions will still be there, but we'll have negative coefficients. So -5 over a minus 4 over b minus 1 over c equals -1 times -1 gives us a +1. Now, this is key. We'll notice that the 1 over c's cancel out. And if you kind of think about it, 1 over c plus -1 over c. Remember, you keep the common denominator. 1 plus -1 ends up being 0 over c, which ends up being 0. But a lot of times you probably don't want to think about it. You're just saying, okay, yeah, as long as the numerators are opposites and the denominators are exactly the same, we do get 0 back. So that's really nice. But now we can deal with fractions in the same manner. If you're going to add vertically, as long as you have the same denominators, all we have to do is add the numerators. So 1 plus -5 for the a's, it's going to be -4 over a. And 2 plus -4 gives us negative 2 over b. 1 plus 1 is 2. So right now, you know, although we didn't make anything too much less complicated, at least we got rid of the c. So I'm going to circle that. Kind of the trend here. We circle this and we call this equation number 4. Now, we're going to do this one more time. But remember, our goal is to eliminate the c's, our c terms. So I have to pick another combination so that I have c's involved. It won't matter. We can go with 1 and 2 if we'd like. So I'll write that down. Number 1, I have 3 over a plus 5 over b plus 2 over c equals 0. And equation number 2, I have 1 over a plus 2 over b plus 1 over c equals 1. Now, the whole goal is to eliminate the c term. So write yourself a note. We're eliminating the c's. So if we're trying to get rid of the c terms, we'd have to find a number that both 2 and 1 both go into, which is 2. So our goal to get rid of the c terms would be to have a positive 2 over c and a negative 2 over c. Well, that's nice because we got the first one already. So you could just write that over again. 3 over a plus 5 over b plus 2 over c equals 0. And the equation number 2, if I want to turn that into a negative 2, I need to multiply both sides of the equation by negative 2. So if I do that, I will have negative 2 over a minus 4 over b minus 2 over c equals negative 2. So now if we add vertically, we'll notice that the c terms do cancel out. We'll simplify a little bit. We have 4 over a, 3 over a minus 2 over a is 1 over a. 5 plus negative 4, we have 1 over b. And 0 plus negative 2 is negative 2. So right now, we have another equation. And if you kind of look at what our pattern was, the goal is eliminating the c terms twice for 2 separate combinations of equations. Whoops, I was going to highlight that. Guess it didn't get the memo. There we go. Eliminating the c terms twice for 2 different sets of equations will lead us with 2 equations with the same variables involved. So you probably guessed it. We are going to pair those 2 equations up and solve that system. So that is equation number 4, which is negative 4 over a minus 2 over b equals 2, paired up with equation 5. That is 1 over a let's see if this will write for me, there we go, plus 1 over b equals negative 2. So now our goal is we're either going to eliminate the a terms or the b terms. So, you know, it's up to you. They both already have opposites, so, you know, I'll take it. What if I want to eliminate the a terms? So I'll kind of write myself a note. I'm eliminating the a term. So if I do that, my goal would be to figure out a number that both 4 and 1 go into, and that is a 4. So the goal would be to have 4 over a and negative 4 over a. Well, we got the negative 4 over a already. So we could just recopy that over. Negative 4 over a minus 2 over b equals 2. And then our job would be to say, well, how do we turn the other one into a 4 over a? we'll multiply it by 4 on both sides. So that will leave us with positive 4 over a plus 4 over b equals negative 8. And now we add vertically. The 4 over a terms cancel out. Negative 2 over b plus 4 over b is 2 over b. And 2 plus negative 8 is negative 6. Now this is not as exciting as our last examples that we've done, but this is now an equation in one variable. I guess, well, actually it's more exciting because it's a little more complicated. So I don't know, maybe you're not so thrilled. But remember, the idea is to solve this equation. So don't forget to solve this. And it's an equation, it's a rather nice equation. It's kind of like a proportion. So we could multiply both sides by b. We're not really getting rid of the b. So that would leave us with a 2 on the left-hand side and a negative 6b on the right-hand side. And from there, if you solve dividing both sides by negative 6, be careful with the 6's and the b's. That tends to confuse me as well. This time I'm going to get b equals 2 over negative 6, or very nicely, negative 1/3. I like to reduce. So now what I can do, there's more than one way to approach this. If you wanted to, you could perform elimination again, and this time eliminate the b term, and you could solve it, or you can plug in negative 1/3 into the particular equation. I don't know what's worse, or like what leads you to more issues, but I don't really like performing elimination too much. So I may plug in negative 1/3 into one of my equations. And the equation that looks a little bit more friendly to me is the 1 over a plus 1 over b. So 1 over a plus 1 over b equals negative 2. It's a little nicer. Now, you just have to be a little bit more careful with the fractions, because if b is negative 1/3 and you're plugging this in, let's move that up a little bit. That title of the page is a little bit in the way. There we go. Okay, so see what I did is I'm plugging in for b, and I noticed that b was in the denominator, still equaling negative 2. Your goal is to kind of understand, well, what does it mean to be 1 over 1/3? And off to the side, you can do the work if you'd like. Really, when you see 1 over 1/3, that's the same thing as saying 1 divided by negative 1/3, which is the same thing as saying 1 times negative 3 over 1, which is negative 3. So you can now simplify this part right here to 1 over a minus 3 equals negative 2. So a little bit of math involved. You could use your TI as well. There's no shame in that as long as you're dealing with numbers. But again, we still have to solve for a. So you have to add 3 to both sides. And then you're going to get 1 over a equals, this time it's a 1. And I'll move this out of the way for a second. Put this over here for now. It's kind of what I'm labeling. I'm trying to understand. Oops. That this is the same. I'm solving for a, so if I multiply by a on both sides, this one's not so bad. I do get a equals, or 1a, 1 equals 1a, or a equals 1. I have to go off to the next part of my screen for that. So I have a and b, and guess what we're going to do? Plug that a and b into one of the original equations and get your C. So, you know, your guess is as good as mine. Which one is the nicest one to pick? And I really don't have an answer for that. But I will write out, just so that we see this, I do have A is equal to 1, and B is equal to negative 1/3. Maybe for sake of doing a lot of math, I may choose the top equation, just because. Maybe there's a 0 on one side, it makes my life easier, I'm not sure. We'll see. So if I'm plugging this in, just make sure your eyes don't skip. That's why I like to write them right by what I'm plugging in. So if I'm plugging in for A, I should have 3/1 plus 5 over negative 1/3 plus 2 over C equals 0. Now we can kind of clean this up a little bit. 3/1 is 3. 5 over 1/3 is negative. And if you're you could use your calculator, but we could say, what is this? A little bit of work off to the side. 5 divided by 1/3 is the same as 5 times negative 3/1, which is negative 15. So 3 minus 15 plus 2 over C equals 0. More than one way to approach this. If we say 3 minus 15, combine your like terms, we'll get negative 12 plus 2 over C equals 0. If you would like, you can move the 12 over. You can add 12 to both sides. More than one way to go. So 2 over C equals 12. We want to solve for C at the very end. We multiply both sides by C. Or it's a proportion, you could also solve it differently. So I should get 2 equals 12C. Solving for C almost, divide both sides by 12. And 2 over 12 reduces to 1 over 6. So we do have all three answers. What is our solution? We have the ordered triple, or ordered triplet, however we want to say. We assume that we're dealing with A, B, and C, usually the alphabetical order. So that's going to leave us with C is 1/6, B is negative 1/3, and A is 1. So, take a deep breath. That was a sprint. There's a lot of algebra involved. It's really, really good for your brain, though. It's like a lot of exercise going on there. I encourage you, just take your time through this. Color coding, again, is the best way to stay organized. And even if you kind of get lost along the way, as long as you're trying to follow through, at least you're understanding the process. So take your time. There's about 3 or 4 homework problems that also deal with the same type of issue. Practice. Maybe you want to solve this without me. Again, one more time to get that practice in, and then attack your homework. So I hope this helps. I will see you in the next example.